Hey class, in today's lesson we're going to talk about arithmetic sequences and partial sums, which is found in section 9.2 part 2. Our objectives are to find the partial sums of arithmetic sequences and to use arithmetic sequences to model and solve real-life problems. So this formula will give us the sum of our arithmetic sequences that we've been practicing from the last lesson. So S sub n stands for the sum of the n terms. So the sum of maybe the first 7 numbers or sum of whatever, that's what it means, okay? N we know means the number of terms. A sub 1 is the first number. And A sub n, again, we know this, means the number at the nth term. And sometimes, a lot of times, it's the last number. And in the last lesson, a lot of times that's what we were solving for, but this time we're not. Well, we might. Let's see. Okay, so example 5, it says finding the sum of a finite arithmetic sequence. So find the sum of 1 plus 3 plus 5 all the way up to 19. Again, steer away from using simple addition like in a calculator and solving it up to that point. Again, that's a skill that I know that you know from a calculator, just common sense. But your job is to apply the formulas that you know how to use it. So the formula that we would use is S sub n equals n over 2 times the sum of the first number plus the sum of the, include the sum of the first and the last number. There we go. That's what I'm trying to say. Okay, so for us, we know A sub 1 and we know A sub n, and clearly they're asking for the sum, so that is S sub n. The issue is we don't know n meaning the number of terms. Now again, you could use your fingers, right, to count it out and find n, meaning the number of terms. But what we're going to do is we're going to apply the last formula that we're using so that we can find n. So again, our goal is to find n. Once we know what n is, then we can apply our sum formula. So let's go back to the other formula. The other formula was A sub n equals A sub 1 plus, or just A, plus n minus 1 times the difference, okay? A sub n, the last number being 19. Okay, don't know what just happened, sorry. Being 19 equal to A sub 1 being the first number is 1, plus we don't know what n is, so that's what we're looking for. And the difference is, again, the difference between the numbers, the difference between 1 and 3 or 3 and 5, you just take the second and subtract it from the first. So that's going to be 2. So our goal is to solve for n. So here we go. We have 19 equal to 1 plus, distribute the 2, and you get 2n minus 2. Positive 1 and negative 2 will give you negative 1. If you add 1 to both sides, you'll get 20. And then finally, n equals 10. Okay? Now that we have n equals 10, we will use it for our formula. So S sub n is now S sub 10 equal to 10 that we just found over 2 times the first number, which is 1, plus the last number, which is 19. So this will give us S sub 10, or the sum of the first 10 numbers, equal to 5 times 1 plus 19 is 20, and that's going to give us 100. So 100 is a sum of those first 10 numbers. Okay, let's try one very similar to that. It says find the sum of the integers from 1 to 100. So this one more so made you have to use a little bit of logic. And on this one, I wouldn't force you to use the other formula, because using logic, you know that the digits from 1 to 100, the amount of digits would be 100 digits, right? It'd be 1, 2, 3, 4, 5, 6, right? If we didn't know that, we could still use the formula and we still get n equal to 100. So with that being said, using the formula S sub n equal to n over 2 times A sub 1 plus A sub n, you'll get 100 over 2 times A sub 1 is 1 plus A sub n is 100. So this would be 50 times 101 will give you the sum of the first 100 numbers, or the sum of the first 100 digits would be 50/50. I don't know about you, but this is something that I used to do on a calculator when I got bored. I would just say 1 + 2 + 3 + 4 all the way to 100, and this is the number that I got. So anyways, this is our answer, 5,050. All right, let's look at our next example. So for example 6, we are finding a partial sum of an arithmetic sequence. So this time it says find the 150th partial sum of the arithmetic sequence. Now, as a reminder, partial sum just means finite, meaning it has an ending. So it's going to stop at the 150th number, okay? So for us, if we want to find the sum of that, again, the formula would be S sub n equals n over 2 times a sub 1 plus a sub n. What's nice for us is that if I want to use this formula, let's see what we have. So S sub n would be 150 because they're telling you to use the 150th term. We know the first number is 5. That's what it starts with, but we don't know a sub n because we can't, it's somewhere at the end over here, right? So with that being said, we have to use the other formula so that we can find it. So a sub n will be a sub 1 plus n minus 1 times the difference. A sub n would be a sub 150 because we know that n is 150. The first number in the sequence is 5, plus the number of digits, or number of terms, is 150. And then the difference, well, the difference between 5 and 16 is 11. So we would have 5 plus 149 times 11. 149 times 11, let's see, plus 5 is going to give you 1,644. So that's the 150th term. So if I apply that to our sum formula, then the sum of the 150 numbers is going to be 150 over 2 times the first number in the sequence plus the last number in the sequence. Okay, that will give you 75 times 1,649. If you multiply them together, you are going to get 123,675. All right, let's look at our very last problem. So of course we were going to run into a word problem, so let's take a look. So it says an auditorium has 20 rows of seats. There are 20 seats in the first row, 21 seats in the second row, 22 seats in the third row, and so on. How many seats are there in all 20 rows? So the fact that they said in all 20 rows, that means they're asking for a sum, right? So let's go ahead and set up our sum formula. The sum formula is S sub n equals a sub, sorry, that's not right, n over 2 times a sub 1 plus a sub n. Okay, n we know is going to be 20 rows, so this is going to be S sub 20 equal to n is 20 over 2. The first, a sub 1 would be the amount of seats in the first row. So the amount of seats in the first row is 20. However, this is where we're going to get stuck, because without counting on our fingers to just get to a sub n, we're going to need to use the formula. So let's use the formula to find a sub n. So a sub n will be a sub 1 plus n minus 1 times the difference. A sub n would be a sub 20 equal to a sub 1 is 20. Yep, there are 20 seats in the first row. Plus n, meaning there are 20 rows, minus 1 times the difference between the rows of seats would be 1. Okay, so 20 minus 1 is 19. So 20 plus 19, there are going to be 39 seats in the 20th row. And I would write that out, but I just don't have the space. So there are 39 seats in the 20th row. So we're going to do 20 for the first row and 39 for the last row. And that will give us 10 times 59, which is going to be 590 seats in all 20 rows. Or 590 seats total. Okay. Alrighty, so we are done. If you have any questions, please be sure to come see me.